Welcome to our presentation on RiverNET. RiverNET is part of Envision Yellowstone. We call it the Internet of Nature's Things, but it's one of our many projects that we're involved with. Our mission at Envision Yellowstone is to empower local communities and citizen scientists, outdoor and recreation and tourism businesses, private landowners, conservationists, and public land agencies with high-density real-time data and machine learning and AI models on natural ecosystems. We call it the Internet of Nature's Things. What's unique about our process and how we fund this is we're not just looking for charitable handouts. We fund these startups or capital costs of our regional projects through traditional charitable gifts and grants, but we fund ongoing support and management and OpEx costs with subscription-based services that people pay for. We call them projects. Our current projects at Envision Yellowstone, our big one is focused on online mapping platforms for real-time predictions of what-if scenarios in the greater Yellowstone ecosystem. The platform allows users to input simulated natural events like forest fires or thunder showers, as well as management efforts like culling herds and deforestation. It then creates realistic projections from these events over selected time periods. We're currently focused on three following use cases: RiverNet, which is focused on water quality and quantity; MigrationNet, which is focused on animal migrations, dispersal, and interactions with livestock; and LandscapeNet, which is focused on changing landscapes due to human and natural disturbances. You can be contacted by us to hold what we call as a geo-design effort with your local community, where we bring in various stakeholders, private landowners, public agencies, and others, and do fast-paced 2-day workshops that gets people together and finds common ground on how they want to manage their local area. We'd like to start this presentation with a quote from a famous person. You see it used a lot in the business world as well. William Edwards Deming is a famous American statistician, a professor, author, lecturer, consultant, best known for his plan, do, check, act cycles. But he came out with a pretty famous quote: "In God we trust, all others bring data." And that is the underlying premise of our work. Many times in the West, when you're fighting over water and you're drinking whiskey together, there's a lot of finger pointing that goes on without any data. So we want to start first with the data, and data definitely needs to be interpreted and figured out how you want to use it. But without data, you really have nothing to go on, and you end up in emotional finger pointing cycles. So we're starting with that premise that by doing this, we can get closer to actionable events in local communities. What we're trying to do is take the successes in weather forecasting that has happened over the last 60 years and apply it to ecological forecasting with some of the same tools, technology tools that have come out primarily in the last 10 years in AI and machine learning. This chart is fairly simple, but what it shows you is if you go back to 1955, the sort of weather predictions we would get on our local news stations could basically get you in one day. You could get a one-day forecast that had a certain amount of accuracy. This case, 20% accuracy. I'm sorry, a 3-day forecast. So back in 1955, we weren't really accurate at telling you what was going to happen in the weather 3 days from now. In 2005, we're up to almost an 80%, and now we're pushing up into the 90s and lower 90%, and that's because of some of these new technology tools. We want to apply those successes where large, vast amounts of government-funded data collection has increased the accuracy of what we can predict, and therefore what we can do with those predictions. You see this a lot in your common life, just through certain technologies that are showing up. Just these 4 companies, starting from the left, Siri, you talk to your phone, it predicts what you're talking about and can come back to you with answers. You can do the same with Google, you can do the same with Alexa, and with Cortana from Microsoft on the right. Those technologies that have inserted themselves into our daily lives are based on some of these same AI and ML technologies that we're using as part of Envision Yellowstone. This technology is getting so prevalent that the financial industry is starting to realize the implications to economies. This is just a quote from Byron Wien, a very famous investor at BlackRock, who makes predictions every year, and this was one of his predictions. Artificial intelligence gains visible momentum in 2018. Service sector jobs are automated, particularly clerks in legal and finance professions, as well as workers in fast food outlets and healthcare. Economists begin to question the unemployment data because the rate drops below 4%, while so many people still appear to be out of work and seeking government assistance. I'm not going to get into the philosophical debates around that, but what I am going to argue is that this technology is having such a profound impact in our society that economists are starting to realize the impact. Those impacts can be good and bad. We think that ecological systems and natural systems can benefit from this if used in the right way. Here's an example, just a simple object classifier. An object classifier in machine learning is it's technology that's used, software technology that's used to predict what's in an image, what objects are in an image. So if you give a computer a picture, it'll tell you what sort of things are in it: a cat, a dog, a person. Which person? You see this in your everyday life all the time, whether it be on Facebook or in your photo app where it can tell you who's in it. So I did a little sample with this, and this is my home office, and I look right out on the Yellowstone River and the Immigrant Peak in the background, and I used my computer from home, just an average everyday computer, and I used some software from Microsoft called customvision.ai. And what I wanted to know was how many boats are flowing by my place on the Yellowstone River. We're seeing an increase in tourism traffic in this area, and no one really knows because it costs too much money to sit out there and count how many people are floating by. But with this technology, I was simply able to load a bunch of known images. In this case, it was about 500 images, train them, tag them, and say, this is a drift boat, this is a fishing raft, this is a kayak, this is a paddleboard, this is a raft, and treat those all as kind of a boat at a high level, and train a system, and then predict an actual boat picture of something floating by my place. So with a simple webcam, I could set it outside my window, a boat would float by, or something would move by on the river, it would take a picture, it would use this software to say, is that a boat? If it's a boat, what kind of boat is it? And then count how many people were in it. And with that simple counter, I can turn it on and come back to it 2 weeks later and see how many people floated by my place in a certain time frame. And this is done with very cheap, inexpensive technology. And then you can start getting a read on how many people are coming by and using a natural ecosystem. So it's important for our project like RiverNET. So that's just an example of how the technology can. Let's talk about RiverNET and what we're doing with RiverNET. It's an AI for trout project. It's primarily focused on the fly fishing community, but it's bigger than that. It's really about other things like water quality. We treat trout as kind of a canary in the coal mine. They can tell us a lot about the quality of water in your watershed. And so that's why we call it an AI for trout project. The types of data we're going to be collecting and are collecting, one is eDNA. It is a fingerprint, a DNA analysis that you can look in the water, see DNA, and then know what species are in that area. It's a very powerful tool that scientists are using, for example, in the USGS, to figure out if there are certain diseases in the river system. The other data we're working with are water quality data, pH, temperature, nitrates, phosphates, ammonia, and heavy metals we're collecting. Water flow, how much water is coming in and leaving a certain stretch of the river. That can be used for water budgets, like how much do you allocate for agriculture, for municipal usage, and make sure that there's enough left over for the ecosystem. And then the last is red counts. That's really cutthroat trout spawning in tributaries, how many of them are spawning, and that shows you how much fish population growth you could have. So those are some of the main focal points we're collecting in the RiverNET project. Why we're doing it in this particular area on the Upper Yellowstone, in August of 2016, there was a big whitefish kill, and it led to various agencies shutting down the Yellowstone River to tourism or any use. And this made it in the New York Times. It was a pretty big deal. And in August, if you know anything about this area, it's heavily dependent upon tourism as an economy. In fact, tourism in Montana is about equal to agriculture and revenue. Those are two big economies for us. So when you shut down an ecosystem, it not only impacts the ecosystem you're talking about because of whatever happened, in this case a disease, but it also affects economies and local citizens that live there. So in 2016, we had this big fish kill. They closed down the river, and there was a big public meeting. And what we learned is that we don't know a lot about why. We know some things about why. We know what the disease is and what caused the fish to die. What we don't know is why this parasite got so concentrated at this particular time. A lot of people, initially pointed to water temps and flows, but this year wasn't a year where it was low flow and high temperature. So that wasn't the cause. And frankly, we just don't have enough data to go and figure out the cause. So 2016 left, it's 2018. We're coming up on a 2-year anniversary. What do we know now? Well, the honest truth is we still don't know. And by collecting more data, we'll have more points of information to figure out what is causing this and then act on it. So that was why we started this. It's not the only reason we're doing this, but it was a big trigger event in this particular area. Essentially, what we're trying to do is take all that we're learning in weather forecasting and apply it to something like fishing, right? Predicting whether there's going to be a lot of trout in the river, or if fishing's, if you're really like me, I'm a fly fisher person, I'd like to know, hey, is it going to be good fishing 2 days from now? And then plan my schedule accordingly. So answering those sort of predictive questions that we have, is it going to be muddy? Therefore, I'm not going to go out. Will there be a likelihood of a hatch? Those sorts of things can be predicted with this data. And it gives you a good sense of how we're leveraging all of this technology that you see in something as simple as a weather forecast that we all use, but apply it to other niche areas like the tourism industry. So here's what we're collecting. We're putting in real-time sondes at certain locations. This is a map down here on the bottom of the Upper Yellowstone area from Gardner to Livingston. And we're putting different types of sensors in there that'll do real-time monitoring, things like water flow, water temperature, and whatnot. So we'll immediately know if there's some trigger event, and people can sign up for the service and get alerts. We're also collecting water quality information, and this is more of a manual process, but it's fairly low cost. We're working with Guides for Conservation, who are floating the river on a regular basis, and private landowners to simply go and collect a water sample. They turn it into our lab. We sample the data for various chemical analysis, and that data is immediately posted on the internet in a report that people can go back to and look at. So it's near real time. It's within 24 hours. And really, if there's a trigger event, like a big explosion in nitrates, you want to be able to deal with it within the time frame that you're, exposed to it. You don't want to wait 2 years later after USGS or DEQ does a sample. As a local person, you want to go find out what happened and can I make a difference. We're also working with USGS, who is doing the analysis on eDNA and helping them collect their water samples. And this, again, is due in large part to an organization called the Guides for Conservation, where guides are out on the river on a regular basis and they can collect these samples with their guests and teach them about citizen scientist efforts. The other thing we're doing is physical red counts, and that's where we go out on a stream and we count the number of spawning beds that trout are in. And we do that when they spawn. With the case of cutthroat, it's usually in the first part of July. We collect that data and we post it on our website as well. Some of the predictive models we're creating that'll help us use this data for practical things are listed on this slide. So we're trying to predict fishing activity. That's the nirvana, right? We're using supervised learning neural nets and various indicators like snowpack, current precipitation, flow, air temperature, pressure, nitrates, ammonium, other things. And it's a simple KPI for a 10-day forecast of fishing activity based on our proprietary neural net. And we get feedback loops from actual users. So we have a mobile app where they say, hey, fishing's good right now. And we stamp that, just like I showed you earlier, where I had to tag an image and say it's a boat. Once I train the model gets better at its predictions, and then I can continually train that model with real people out there using it and saying, hey, it was good fishing or it wasn't good fishing. Another example is water flow, and we're using climate models for that. So snowpack, micro weather stations, and trying to do 3-day prediction forecasts on how much water might be coming through in a particular area. We're doing fish populations through a proprietary population model. You know, how many fish will be in the river next year or 3 years based on what we know today. Turbidity and temperature are also good things to know and be able to predict out. Like I said earlier, is it going to be muddy in 3 days? Then I might not want to, if I'm a guide, I might go figure out another place to take somebody. And then last but not least, and probably most significantly for the greater public, is water quality. And these are unsupervised neural nets where we'll be able to predict, hey, is water quality safe for livestock or for human consumption? Those are the things we'll be rolling out because we have this data. Our first set of data is in. We launched last week through a collection process, and we tested from Gardner to Livingston, Montana. And we found some anomalies in that data. You can see over on the right here on our webpage where all of this data is being streamed out for the public, and they can go in there in this particular case, look at a particular site and compare different data that we've gotten over a time frame. So I might be able to look at my site on the river and go over this summer, you know, when did I have peaks in nitrates or flows, other things, and then start making decisions on why that might be the case. There's many different possible explanations on what might trigger an anomaly. It could be a large ungulate concentration of bison or elk in a particular area. It could be a lot of cattle in a particular area. It doesn't need to be just natural or just human. It could be one or the other, or a combination of both. It could have been a forest fire that came through 10 years ago that, you know, has a material change on soil, and that can be reflected later on in our tests. It could be a septic system that maybe isn't operating properly. It could be a car pit where a lot of trash is collected that could be leaching into groundwater and now making its way into surface water areas. Once we get those anomalies, we can send out small teams to go collect other water quality samples in the surrounding area and narrow down what might be the cause. And then when we don't think we know what's going on because of the data, we can give it to scientists and they can do the hard, heavy lifting that can sometimes take months and years to figure out what's going on. But without the data, they're not going to be able to do an analysis. So that first set of data is in. It's published on the website. You can go to the link right there at the top and start looking at that data as we release it through the rest of this summer. The team, we've got a scientist, our chief research guy, Bob Crabtree, very well respected in this area as a scientist. I'm leading the charge, coordinating all the different people. And then we have a technologist, chief technology officer, Ashish Parikh, who's making sure our technology is the best and he partners with various tech companies like Microsoft and Google and others to bring the best tech that they have to this particular natural ecosystem project. Just the three of us. This is a large team. We have a science and conservation advisory board from various organizations that are helping create the models in particular and helping make sure that we're doing this in a way that benefits all stakeholders. Not just conservationists, not just agriculturalists, not just municipalities. Everybody has a stake in these problems. And then we have a lot of collaboration partners. Like I said, we have some tech partners. Microsoft and Arrow are the key ones right now. We have different agencies and NGOs like USGS, DNRC, FWP, the Greater Yellowstone Coalition, the Arthur M. Blank Family Foundation. And then we've got some industry folks as well, from Sims Fly Fishing out of Bozeman, Trout Unlimited, Fly Fishers International, and Sage, who has a lodge in this area. So we have a lot of partners representing all of these different stakeholders so that we're getting all the voices and the data can be used to multiple people's benefit. So I want to thank you for that brief introduction, listening to this brief introduction of RiverNet. You can contact me here if you want to learn more about it and meet with our team and get involved. On our website, we're launching a Adopt a River approach to this, where you can adopt a stretch of the Yellowstone or a tributary and put your own company's brand on it, and you'll be responsible for that particular stretch and collecting data and working with us on a grander scale. So make sure you go to our website, upperyellowstone.org/RiverNet, and you can get all of the current information that we're publishing and ways to sign up and contribute to the effort. Thank you very much for your time.